Hello. So welcome to episode 175 of eCHO. Today I'm going to be talking about everything that's happened in the past couple of releases of Tetragon. So if we've not met, my name is Paul. I'm a community builder at iSurveillance, primarily focused on security. Today we're going to be talking about everything Tetragon, right? So just to keep up with what's been happening in the Cilium community, a good way to keep up with what's been happening with the Cilium community is the eCHO newsletter. It's a bi-weekly newsletter that Bill curates. So if you want to learn more about the eCHO newsletter, you can always find that on the Cilium website. I'm just gonna can share that. If you go to the Cilium website, a news and media newsletter, you can subscribe to eCHO and you'll get everything that happens with eCHO. Get everything that happens with eCHO in your everything that happens with the Cilium and the eBPF community. You will get that in your mail. All right. So and yep, that's one of the best way to keep up with the Cilium community. So today I'm going to be talking about what's happened in the past two releases of Tetragon. So if you're hearing about Tetragon, Tetragon is security observability and a runtime enforcement tool from the creators of Cilium and eBPF, right? So Tetragon uses eBPF for observability and runtime enforcement. And the thing about Tetragon is able to, this security observability and enforcement that Tetragon does, Tetragon ties it with cloud native identities, right? So you're able to bring all the identity from like your cloud native concepts like Kubernetes port, Kubernetes nib-belts, and tie this with specific like security related constructs. For example, you want to like say, for example, prevent file integrity monitoring, for example. You want to be able to do this in the context of like Kubernetes or in the context of cloud native environments, right? So Tetragon sort of like marries these two together like in a very, very efficient way that makes it, that's able to like protect your cloud native environments effectively. So Tetragon also works outside Kubernetes. You can have Tetragon running in your Linux environment. All right. So if you want to learn more about Tetragon, you can go to tetragon.io. That's the name of the website. Another place you can keep up with Tetragon is we have a monthly community call that happens every second Monday of the month. If you go to the Tetragon website, just at the very top of the website, you will see a banner that has a link to all the details about the community meeting, when the next community meeting is, notes from previous community meetings and all of that. So if you're interested in keeping up with that, that's one of the best ways you can learn about Tetragon. So what basically happens in these community meetings is we have like, this is a venue for us to like review PRs. This is a venue for us to review PRs. This is a venue for us to if we have like pending issues, we can also discuss this. This is, for example, if you're speaking at a conference, you need a second pair of eyes reviewing your CFPs. You can always show up at the community meetings, and these people from the Tetragon community will be very, very happy to help you. So if you want to keep abreast with what happens with Tetragon, you should definitely not miss the community meetings. All right, so down to the business of today. So if you've been keeping up with what's been happening with Tetragon, since we had like the 1.0 release, there's been like a lot of like improvements to Tetragon, and like some existing features are being improved and new features are being shipped every day to Tetragon. So basically what today's episode of eCHO is going to be talking about like some of the very features I found like very, very interesting over the past two releases of Tetragon. So we are currently, if we actually go to GitHub, we're currently at Tetragon 1.3, right? And the previous release was 1.2, right? We are going to be just talking about like the features. So to start with, I would want to start with Tetragon 1.2. So on the main iSurveillance website, we have this release blogs specifically focused on Tetragon. So if you actually go here to like the blog list, right, you can come here and just see this by Tetragon only and get like blogs related to Tetragon. So a thing that you should try not to get confused with this. So the isovalent enterprise for Tetragon is has like a different version against Tetragon OSS, the one we can all see on GitHub, right? So you try not to get the versions confused, but it's by two-step forward. So right now, this 1.15 in Isovalent Enterprise corresponds to like 1.3 in Tetragon OSS. All right, so we're just going to start with 1.2. I'm going to start with 1.2, some of the features I found very interesting. So one of the very first feature I found like quite very interesting is something called persistent enforcement. Right. So if you sort of like, if you're familiar with Tetragon, but one of the things Tetragon is able to do is what's called like runtime enforcement, right? So this happens with eBPF right in the kernel, right? So if you've got something that's defaulting, for example, you're saying, hey, you don't want you don't want like a process to be able to do certain action, right? If there's a defaulting process or something, you want to kill that process, the process responsible, like instantly, right? So Tetragon is able to do this, right? And this whole happens like in kernel, right? So in Tetragon 1.2, a new improvement to enforcement was introduced. And so previously, like when you have like the Tetragon agents running, for example, right? And for some reason, we know like in the live production environment, things could go wrong. For some reason, the Tetragon agent goes up, right? Goes down. The eBPF programs responsible for actually implementing like this enforcement actually also are also removed, right? But persistent enforcement basically allows like this allows this eBPF programs that are responsible for enforcement to continue running despite like the Tetragon agents being down, right? So why is this very important? So this is very important for one, like increasing, like strengthening like the security posture of Tetragon. And we know like it's, for some reason, like things are gonna happen like in a typical production environment. Like it's not every day that's gonna be like a nice day, right? It's gonna be like days where like something happens, or you have to like kill the agent intentionally, or for some reason whatsoever, the agent goes down, right? But then you still want like the eBPF programs that are responsible for enforcement, right? To continue to protect you against like threats, right? And this is where like this feature really becomes like very important. So this is one of the first feature I think it's nice for us to play around and just see how this and just see how this works. So to play around with this, what we can do is so to get this working, I'm gonna do like a very simple demo here, and this demo is gonna work with I'm gonna have Tetragon running as a systemd service, Linux environment, right? So if you actually want to see how to get Tetragon running outside Kubernetes, Tetragon works both in Kubernetes. You can have Tetragon as a container, and you can have Tetragon running as a systemd service. So there's parts there's where in the docs that tells you that basically explains how to set up Tetragon to run in as a systemd managed service. All right, so I'm just gonna. I have a Linux PC in my local. I have a Linux PC in my local network. That's running Ubuntu, and I already pre-installed like the latest release of Tetragon on this, right? So we're just gonna use this and play around with that feature and see how this goes. All right. So the first thing we would want to do is so to use this feature, right? You need to configure like the Tetragon agent using like this flag that's called keep sensors on exit. So basically, like the name implies, it keeps like the eBPF sensors for this still keeps them even if like the Tetragon agent is down. So to get this working, so this is a tracing policy that's here. So if you're not familiar with tracing policies are basically like the primary way you configure Tetragon. So this is how you tell Tetragon what to do, what Tetragon should do. So essentially what the state tracing policy says is if any process tries to touch this directory called slash tmp slash Tetragon, right, just kill this process. So there's a mark action here that basically kills any defaulting process that tries to access this directory that's called here. So what we want to do is we want to kick off. So the way to test this out is we're just going to start Tetragon. We're going to start Tetragon, right? Apply this tracing policy. When we apply this tracing policy, we're going to intentionally kill the Tetragon agent and then try and still see if this tracing policy is going to work with the Tetragon agents down. All right. So I already have this tracing policy inside this machine. This is inside this machine here. So I think it's called our enforcement. Yeah, enforcement.yaml. It's the same tracing policy as the one in docs. All right. So we're going to we're gonna start up the Tetragon agent. We're gonna start up the Tetragon agent. So I'm going to make some slight changes to these. I'm just going to remove this at the moment. This should work without this flag. Or keep sensors on exits. Yep, tracing policy. All right, so we have to do this with sudo. All right, so now we have Tetragon. We have the Tetragon agents up and running. Right, so we've got the Tetragon agent up and running. Until the Tetragon agent is now listening for like events, right? So just to verify, like we have everything running, we can use, I have the Tetra CLI installed. So there's a CLI you can use to like interact with that query that basically queries I think it queries the gRPC API, I believe, that Tetragon has, and you can use this to interact with Tetragon. All right, so we can use Tetra. I think there should be all right. I'm on my local PC. I have to say. All right. So we can use the Tetras. So we can say a Tetra. There should be a flag here. It essentially allows us to see all our tracing. We can query for all the tracing policies. So we can say tracing policy, I believe, lists. Again, that needs to be, what's a sudo? Right, so we can see we actually have this tracing policy being in effect, right? So one thing to remember is I'm not using Kubernetes here. I just have Tetragon running as a systemd service in a typical like Linux environment. So we can actually confirm this to see systemctl status, I believe, Tetragon, right? So we have a Tetragon. You can see like we've got Tetragon up. All right. So all right. So we want to see if this tracing policy, right, works. So one thing, the way we can test this is let's just try cat the /stem/tetragon directory. We see like this process is killed like instantly. So this is actually the enforcement tracing policy being working, right? You see, we try to assess this and then this is killed, right? Now, how do we know this policy how do we test that the persistent enforcement is working? We can just go and intentionally kill like the Tetragon agent. So to kill the Tetragon agent, we can do this, just hit Control-C, and that should kill like the Tetragon agent, right? Now the Tetragon agent is down, right? Now let's try access this, and you can see this tracing policy still works despite the Tetragon agent down. If you try using like the Tetra CLI, I believe you see you can actually reach like the Tetragon agent, right? The Tetragon agent is down, but if you try to access the same directory, you can't do that. This is because the eBPF programs responsible for enforcement still work despite the Tetragon agent being down. So I kind of found like this feature like really, really interesting because you can instantly, you can actually recognize how this plays a very big role in like strengthening like your security posture, and how this helps to like just cover like the gaps that you typically like cover like the security lapses. All right, so that was one of the first feature I found interesting. There's a tiny demo on the docs that describes how to like just go about this example I just did, but it's pretty much like pretty straightforward to get started with. And in my scenario, I'm using Tetragon as a system managed service on Linux. So this is such an interesting feature, and I really found it interesting and wanted to talk about this on today's eCHO Live. And the other thing I want to talk about is support for like for Cryo, right? So Cryo is like a very popular container runtime for like Kubernetes. So if you, just in case I might be this, because just in case I might have the pronunciation wrong, this is what I'm talking about. This is Cryo is a lightweight container runtime specifically designed for like Kubernetes, right? So in a couple of releases back, Tetragon had shipped support for Cryo. So just to give you like a timeline of what happened, of how we got to this point, right? So for Tetragon to be able to function properly, like in a Kubernetes environment, Tetragon needs to like correlate like all this cloud native metadata, all this Kubernetes metadata, like the pod, the container name, the labels, and all of that correlates this with its security and observability, like and runtime enforcement mechanisms, right? And one way Tetragon is able to do this is by fetching like this Kubernetes metadata from the Kubernetes API. But in certain cases, like this is usually not ideal. Like for example, in like cases of like an enforcement policy, right? Because this only happens like you don't get like this data like in real time, and there's usually like there might be like a delay in between like when like a container starts and when like the policy is applied, right? which which could be like a lapse, right? So Tetragon took like a different approach, and the team started using OCI runtime hooks and hooking right into like the container to the container runtime. I believe this is OCI or runtime hooks. So this runtime hooks allowed like you can actually see like the spec for this. I think there's a spec for these like at different stage of like on a different life cycle of a container. You can hook in and retrieve like all of this Kubernetes metadata, right? Before a container is created, when a container is creating, when a container is running, and when a container is stopped, and the runner is able to use this data and to then attach like its security observability and runtime mechanisms, right, to the environment, right? So this evolved again. From so when support for container D came. So container D is this, I believe, container D. This is also a very popular container runtime, and this is like this underpins like popular container runtimes like the likes of Docker, right? When support for like container D came in, Tetragon had Tetragon moved away from like using init containers to using like an approach that needed to work for that needed to support both containerd and CR and cryo, right? And how this was achieved was using like a Tetragon runtime hooks daemon set, right? And this daemon set approach essentially ensured that Tetragon had support for both containerd and cryo. So that's how that's sort of like the backstory. That's sort of like the backstory behind like how we got here to this point, right? So over the time, like more like support for like this container runtimes they've continued to ship like more different support for like this container runtime. So now currently both containerd and cryo are like fully supported with Tetragon. So previously, like if you were using Tetragon with like something like kind, you would notice like some slight things that didn't work well because of like the that didn't work well because like kind uses like containerd by default, I believe, and like the small details like this. So lots of these things were really ironed out like what in the past release of Tetragon. All right, so and if you're curious about this, on the main iSurveillant website, there's a blog that actually talks about like you can just come here to Tetragon and you would see there's a blog for like this that goes into like all the details in depth of you can actually follow like how this features basically how this evolved. You can also look at the release notes and see how basically we evolved to the current state. But the crux of the gist is that currently there's full support for containerd, and there's also full Tetragon fully supports cryo and containerd. So you can use any of these container runtimes with Tetragon, and you would not run into you'll not run into any major issue. All right. So we've covered persistent enforcement. We've covered support for both cryo and containerd. And another thing that got some improvements, I believe, over the past few releases is if you look at the policy library. So we've got this we have this lot of this sort of like pre-made tracing policies that can for like very common like security use cases. You can find them on in the Tetragon docs, right? So basically with Tetragon, you can basically monitor like the eBPF subsystem interaction, right? To see all other programs like interacting, like all the programs. So for example, you could have other programs using eBPF for like other reasons in your cluster or in your environment. With Tetragon, you can actually monitor like things that are interacting like with eBPF in your environment, right? So there's a very nice talk. I think it's called "Watching the Watcher," I believe, by John and Natalia. If you go on YouTube, it's a KubeCon talk. If I remember, it's either a KubeCon talk or a Cloud Native Security Con talk. I can't remember correctly, but it's called, I think, "Who Watches the Watcher" or "Watching the Watcher." From John and Natalia, basically dives into like the details of how Tetragon is able to like monitor like the activity of the eBPF subsystem, right? So we know like with eBPF comes like let's say with great power also comes like great responsibility, right? eBPF is able to do things has almost unfettered access to like what's happening in the kernel, right? So it's always a nice thing to be able to like just have some visibility into what's happening, into what other programs using eBPF are doing in the kernel. All right, so we've covered that, and if you want to, this is right in the doc. So if you want to dive deep into this, there's a base tracing policy here that goes into these. You can play around with this and see how this works. All right. So another thing, just to talk about, back to cryo, I did forget to mention is, so one of the improvements to like cryo, basically what this also does is it basically improves how like Tetragon associates like Kubernetes pod metadata with processes when using cryo as the runtime, right? So if we actually look at the release note for the last release, I believe it's the PR. I believe it's this PR, right? So basically, previously, like Tetragon will use C group names to like link like processes to their Kubernetes context, right? But this wasn't always like reliable. It was prone to like it was unreliable, right? So basically, one of the major one of the major like changes in this release is that this evolved from like using like C group names. Instead of using C group names, you have like C group IDs being used to basically fetch like the Kubernetes, the metadata directly from cryo, and then use this to associate like the process with the Kubernetes context. And this basically what this essentially does is basically strengthens like the connection between Tetragon's like security enforcement security observability and runtime enforcement mechanisms, strengthens enforcement with like the Kubernetes side, right? So you have like a more deeper integration with like Kubernetes. So that's basically some of like the very major changes that's happened in Tetragon. And if you want to keep track with this, you can always read like the release notes. So just to close up this, we've got this. I think that's pretty much like the major things I want to discuss today. So if you've got any questions, I'm all listening. But so we've got this case studies from the CNCF we do every once in a while, and we're looking out to do some more for Tetragon, right? So if you're an end user of Tetragon and you want to share how much Tetragon has been an impact, how you use Tetragon and how Tetragon has impacted your project, be sure to reach out to anyone in the community team or anyone you can reach out to Bill, reach out to Liz, reach out to anyone, and they're gonna help you. They're gonna help you basically help you document this and funnel you to the right people to help you do this. So be sure to like reach out if you want to share how you've been using Tetragon in your environment. If you want to share this with the wider Tetragon community, and also you can also stop by the community call every second Monday of the month. And we're going to be at KubeCon in London. So if you're going to be in London on the 1st of April, be sure to stop by the Cilium booth. There's a blog here that details all the Cilium-related talks we're going to be having at KubeCon. So there's going to be lots of talks about KubeCon, about Cilium. There's going to be lots of talks about Tetragon. So if you're going to be at KubeCon, you should make sure you stop by the Cilium booth, say hi to us, and we'll be very, very happy to meet you. So the Cilium booth is at, I believe it's at Kiosk 5B in the project pavilion. You can stop by and say hi to anyone at Cilium community. All right, and I believe we've covered everything we're supposed to cover today. But if you've got any questions, you can shoot your questions. And thanks for coming to this episode of eCHO 1557. I believe there was a technical glitch, but so you might see multiple versions of this episode, but this last version is the one without, I believe, without the technical glitch. All right, and have a nice day, everyone. We hope to see you at KubeCon, and we hope to connect with you with the community. Thanks for coming around. Bye.